Hello students, once again welcome to TOS classes for physics, and today I am going to discuss a very important topic in physics for 12th class cbse, and our topic is electric field lines. Okay, what are electric field lines? Every year generally one marks question may be asked that is based on this concept. I am going to understand what are electric field lines. For this one I consider a source charge here. Suppose this is a source charge plus Q. What I have considered? I considered a source charge plus Q. This is a source charge plus Q is a source charge. Okay, that has been placed in air or vacuum. Now, what I will do, suppose I have a unit test charge. What I have? A unit test charge. Very small magnitude, unit magnitude test charge. Suppose this is a positively test charge one, Q naught, and Q naught is the unit positive test charge. This is a unit positive test charge. Okay, so I have a source charge in vicinity, in very near I have placed a unit positive test charge. What will happen? This charge is going to be repelled, and if this charge is free to move, what will be its path? Its path will be like this one. On this path it will move. Similarly, if I put this test charge, unit test charge here, the path, if this test charge is free to move, that will move in this direction, because we know that like charges repel each other. If I consider this unit test charge, which I have considered Q naught, is placed here, so what will happen? It will move along this path. In the same manner, if I place the unit test charge here, the path that is going to be followed, that will be like this one. It will follow this path. Okay, similarly, if I place this unit test charge here, the path followed by it, this one. If I place the unit test charge plus Q naught here, very close to this one, what will happen? If it is free to move, it will follow the this path, because we know that like charges depending. So what I have observed, if I place the unit test charge around the source charge, and if the test charge is free to move, it moves in a straight line, one thing. And actually what you have seen, these are radial lines. They are, if you consider this is the center of a circle like this one, so all of them are radials. So these lines represents the electric field lines. So what are electric field lines? Electric field lines are those curves on which a unit test charge would move if it is free to move. These lines are known as, or these curves are known as electric field lines. First definition. Second definition, electric field lines in an electrostatic field are the curves. Electric field lines in an electrostatic field are the curves. The tangent at every point of it gives the direction of electric field. So this is the definition of electric field. Okay, two definitions we have discussed with you. Now what I have observed, if I have a point charge, source point charge, then electric fields are radial and outward. Very important question, you can be asked in examination. Kindly draw the electric field line due to an isolated positive charge. So due to an isolated positive charge, you see electric field lines are outward and radial and outward. So you have to write down due to a single isolated point charge, electric field lines electric field lines are radial. Radial means that is along the radius of circle, and outward, and outward. Okay, so I have drawn these electric field lines in a different manner, in a small place, so that you can understand it well. If the question comes, suppose this is plus q charge, and this plus q charge, what is the electric field lines due to this one? The electric field lines due to an isolated point charge will be like this one. This is radial and outward. So electric field lines, these are electric field lines, and electric field lines are radial and outward for a single isolated point charge which is positive. Which kind of charge it is? This is positive q. Due to a single isolated point charge which is positive, the electric field lines when isolated in bracket you can write down positive test charge. This is, sorry, positive source charge. Due to positive source charge, electric field lines are radial and outward. In the same manner, I can draw the electric field line due to a source charge which is negative. So the electric field lines will be radial and inward, radial and inward, radial and inward. It means that if we have it means if we have a unit test charge, that is in the electrostatic field, that is in the electric field produced by the source charge, then the negative charge will attract the unit test charge, and this path will be the electric field lines. Okay, so I have plotted the electric field lines due to a isolated positive unit, due to a single isolated positive test charge, and here the electric field lines due to a negatively charged isolated source charge. Okay, so I hope that you can understand it well. You have understand the definition of the electric field. So these lines represent the electric fields. Now I have to draw the electric field lines due to two charges which are equal in magnitude but opposite in direction. Let us see how we can draw that. So if I have two point charges plus q and minus q which are separated by a small distance between them. Suppose this is plus q and this charge is minus q. So electric field lines will be like this one. They will start from positive charge and they will end at negative charge, like this one. Like this one. So you have observed that these electric field lines, they start from positive charge and they end at negative charge. Okay, these are the electric field lines due to two charges which are equal in magnitude but opposite in nature. These are the electric field lines. Okay, what you have see from this diagram, what you have observed, the electric field lines starts from positive charge and they end at negative charge. In the same manner, if I have to draw the electric field lines due to two charges of same nature and same magnitude, what will be the diagram for these electric field lines? So I have to draw this one. This will be like this one. This is positive test charge, like this one. We have to draw. These are like this one. They are going to be like this one, like this one, like this one, here, here, this one, like this one, and these are the electric field lines due to two charges, isolated charges due to two charges of equal magnitude but opposite or equal magnitude and same polarity. Here, there will be a certain point that is in between these two uh, uh, point charges P. This point P is known as the neutral point. Neutral point is the point at which the electric field will be zero. So what we have studied today, we have studied the definition of the electric field lines. Electric field lines are those imaginary lines which are drawn in an electrostatic field. The tangent at every point of this curve represent the direction of electric field. Okay. And what we have learned, the electric field lines due to a single positive isolated charge are outward and radial. In the same manner, the electric field lines due to an isolated negative source charge are radial and inward. The electric field lines due to two point charges of equal magnitude and opposite direction, and opposite nature, equal magnitude and opposite nature, they originate from positive charge and they reach or end at negative charge. In the same manner, if I draw the electric field lines due to two point charges plus q, they have equal magnitude and equal nature, same nature, then the electric field line pattern is like this one. There is a certain point that is in between these two point charges at which the intensity of the electric field due to these two point charges will be zero, that is known as neutral point. So today we have studied the electric field lines, and in my next video I will discuss with you some of the important properties of electric field line. I hope that you understand it well. If you have any problem, then you can send your comment in comment box. Okay, thank you very much. Have a nice day.